During this lesson, you will learn about the autothrottle and its component parts. Then you will learn about the thrust computations made by the autothrottle system and the purpose of the full authority digital engine control system, and the engagement and disengagement criteria. Then you will learn about the thrust computations made by the autothrottle system and the purpose of the full authority digital engine control system. The autothrottle is a computer-controlled electromechanical system that provides the crew with automatic thrust control from the start of the takeoff roll through climb, cruise, descent, approach, and go-around or landing. This is achieved by maintaining a value of thrust, which can be N1 or engine pressure ratio, or a value of airspeed, either indicated airspeed or Mach number. The speed value can either be supplied from the mode control panel, referred to as MCP speed, or the flight management system, referred to as FMC speed, which also provides the autothrottle system with N1 or engine pressure ratio limits. You will now be shown the components in a typical autothrottle system, starting with the heart of the system, the autothrottle computer. The autothrottle computer has the following inputs: pilot inputs from the mode control panel, including arming the autothrottle and selecting the modes of operation, and the flight management system, or FMS. There are also inputs from various other aircraft systems, including indicated airspeed, Mach, altitude, and true air temperature from the air data computer, attitude and acceleration supplied from the inertial reference or inertial navigation system, speed of the N1 rotor from the N1 sensor, the aircraft angle of attack from the angle of attack sensor, the actual height above ground from the radio altitude, air-ground logic from the switch on the landing gear strut, thrust reverse position from the engine accessory unit, and flap position. From the throttles, there are the following inputs: autothrottle disengage logic, which you will learn about later in this lesson, the takeoff go-around switch logic from the switches on the throttles, and throttle lever position from the lever angle synchro. Also, there are inputs from the autothrottle servo actuator, torque switch, a tachometer, and torque switch status. There is built-in test equipment in the flight control computer and FMS. The FMS also provides an input to the N1 indicator. There is a servo motor control and engage and clutch control output through the autothrottle servo actuator. Autothrottle mode annunciation is provided to the primary flight display, and there are also failure warnings and annunciations provided for the crew. With older generation aeroplanes, the engine fuel system supply would be controlled by a hydromechanical engine fuel control unit. More modern aeroplanes allow for electronic refinement of the fuel supply with a power management control unit. There is one unit per engine, and they have limited authority over the engine fuel control unit. When the power management control unit is turned on, it allows fine adjustment of the fuel flow to maintain the desired thrust setting. It achieves this by using the thrust lever angle, N1 speed, intake air temperature, and pressure to maintain the desired N1 speed. This value will be maintained during the climb to keep a constant thrust setting, without throttle lever adjustment. The autothrottle will function normally with the power management control on or off, with the autothrottle computer controlling the flight management system's N1 limits in either case. During autothrottle operation, it is recommended that power management controls be both on or both off, as this produces minimum throttle lever separation. Autothrottle takeoffs may be performed with both power management controls off. Moving the autothrottle arm switch to arm arms the autothrottle. For engagement in the N1, Mode Control Panel, or Flight Management System Speed Mode. The autothrottle arm switch is magnetically held at arm until one of the following conditions occurs. The autothrottle arm switch is moved to off. Either autothrottle disengage switch is pressed. An autothrottle system fault is detected. 2 seconds have elapsed since landing touchdown. Notice the warning light does not flash on this occasion. Or the throttles become separated by more than 10 degrees during a dual-channel approach after flare armed is enunciated. As has been shown, autothrottle disengagement is indicated by the autothrottle arm switch tripping off and the red autothrottle disengage lights flashing. The autothrottle disengage lights can be extinguished by one of the following actions: returning the autothrottle arm switch to arm, pressing either autothrottle disengage warning lights, or either autothrottle disengage switches. The primary thrust parameter is engine pressure ratio, known as EPR, which is the air pressure at the turbine outlet compared to the compressor intake. If EPR is not available, then N1, which is the speed of the first stage of the compressor, is used instead. The thrust lever is therefore used to select a thrust value of either EPR or N1. Full Authority Digital Engine Control, or FADEC systems, are designed to eliminate the problems associated with the older hydromechanical engine fuel control systems. The FADEC is fully integrated with the automatic flight control system and replaces the older fuel control units, although a fuel pump and metering valve are still required. However, they are controlled electronically to optimize thrust with minimum fuel burn. FADEC performs the following functions: full engine fuel control, thrust setting computation, engine limit protection, including N1, N2, exhaust gas temperature, power and acceleration, automatic start sequencing and monitoring, relaying engine parameters to flight deck indications, and thrust reverser activation. During this lesson, you have learned about the components, inputs and outputs in a typical autothrottle system. You saw what was gained from the power management control system. Next, you saw the engagement and disengagement criteria. And finally, you learned what operations the FADEC system carries out.